Hi, I'm David Dusek, a senior writer with golfweek.com, as well as USA Today Sports. And I'm here today to learn about golf shafts, specifically some of the technologies, features, and benefits that go into making Mitsubishi golf shafts. And thankfully, I've got a couple of guys right here with me that know a lot about this stuff. I'm joined by Tod Boretto, who is a composite engineering specialist with Mitsubishi. Todd, how are you doing, buddy?
Good, David. How you doing?
I'm doing great. And once again, I've got Avery Reed, who is the tour promotions manager for Mitsubishi. Avery, how are you?
I'm good, David. Good to see you again.
It's good to be with you guys too. Listen, there are so many technologies over the years that Mitsubishi has designed and worked with to create better performance from golf shafts. And I want to talk about so many of them, most of which are going to be found across a variety of different golf shafts. You guys do a great job of blending different things to try and give people the best performance that they can possibly get out of their wood shafts. And I want to start with a technology that's been around for a little while, but is still being used by a number of different players out there on the PGA Tour, the LPGA Tour, et cetera. Todd, explain to me a little bit about titanium nickel, TINI. What is that material? I know what nickel is, or at least I know it's worth about 5 cents. And titanium is something that I often think of with drivers, but I've never heard of titanium nickel fibers before.
Good question. So titanium nickel, it's commonly referred to as memory metal, or also referred to as nitinol, nickel titanium. And it's got some very special properties in that the metal itself, hence the term memory metal, it has its ability to spring back or return back to its original shape faster, is much faster than, let's say, a carbon fiber in a similar structure. So the nickel titanium comes back to its original shape, and in certain shaft designs, we'll place it up in, let's say, the grip section where the wall gets very thin, and we're trying to keep that wall from ovalizing. And so we want that as that shaft goes under load and it wants to ovalize, the memory metal wants to keep it back to its original cylindrical shape, which is more efficient. So we've also used it in the tip section, depending on the shaft design. So we'll use it in different areas, just depending on the desired properties that we're looking for.
So in a way, it's a material that you can use, or technology you can use, that when the shaft is bending somehow, these fibers want to snap the shaft back into its original sort of non-bent shape. Is that correct? And do it faster.
Yeah, in essence, that's correct. I mean, that's how we're using it in this application, and it's commonly referred to as what's called the collapsing straw effect. And if you take a drinking straw and you go and bend it, and you see in the center where the load's concentrated, that tube, that straw wants to ovalize. And as soon as that happens in a golf shaft, it changes your angle of attack for the face of the head, and so it can affect a lot of different variables. So during that swing, we want to restrict that tube from collapsing or ovalizing, and that's what the memory metal does.
Is this a technology that you borrowed from another industry or another space, or is this something that you sort of worked on, or somebody at Mitsubishi was tinkering with over the course of time and finally got just right? Where did this come from?
It's actually, nickel titanium has been around for quite many years. Actually, it's been used in the aerospace industry, defense applications. Within golf, it's my understanding that we were the first ones to actually implement it within a golf shaft.
Yeah.
And so we've been with the original Kabuki and some of the original parts where we started to try this material and use it and actually implement it. It's been at least probably 4 to 5 years since we've been using it in an actual application, in a finished product. But we've been looking at it like everything. We develop products and materials all the time. So it's just one of those materials that's in our bag of tricks, and we like to use it where it's applicable.
So yet another way that sort of technologies that you guys have found from other industries you've been able to apply and put into golf shaft performance. Avery, what are some shafts that people are going to be using, or that people might find if they go to a good custom fitter, that would have this type of technology inside it?
Yeah, so the big one for us, especially out on tour, and now it's actually making a little bit of a resurgence on tour, was the Kurokage. And everybody nicknamed it the teeny shaft because down at the tip section, we had the Thai nickel logo. So they all knew it as the teeny shaft out there. But obviously, it had a lot of success in the past. It's won a lot of majors. It's won a lot of golf tournaments. It was one of the most popular shafts on tour for a very, very long time.
Now, where is this technology in in that particular shaft? Because Todd had mentioned that in some
Yep.
shafts it's up in the handle, and some shafts it's down in the tip. How is it being used in this one?
Out on Kurokage, we used it down in the tip section. So again, trying to get more consistency for those guys with the higher swing speeds and get that shaft to return back to normal is very key for them. So that spring-like effect that Todd was talking about, it actually performed very, very well for higher swing speeds.
So if you built the Kurokage shaft and you didn't have the tie nickel down in the tip section, what would those elite players feel? How would it change the way that the ball comes off the driver and then flies through the air?
You'd see a lot of inconsistencies. So we'd see
Okay.
spin rates kind of go up, they'd go down, they'd be very inconsistent. We'd see dispersion patterns, we'd see them miss right, miss left. So really, when you can get that shaft to return back to the same spot every time, and they know that they're hitting the center of the club face, dispersion comes in, spin rates stay normal. So there's a lot less inconsistency.
Well, and who doesn't want to hit more fairways and do something like that? So really interesting technology there. Let's
Yeah.
head over to the periodic table, spin it, and we're going to come up with boron. Now, I be honest with you, I did okay. I struggled a little bit in chemistry. I was really good with some of those elements. Hydrogen and helium, get me on the very start. Boron. What in the world, Todd, are you what is boron, and why would it give benefit to a golf shaft?
So boron, David, is a silicon carbide fiber in this case. It's
Okay.
also a natural element, obviously, but in this case, it's in a fiber form. And in doing so, when they manufacture boron in fiber form, it's a relatively large diameter fiber compared to, let's say, carbon fiber.
Okay.
And by design, that larger diameter gives us very high compressive strength and stability in the structure. And so what we do is for typically real high swing speed players, up in the 120 mile per hour and up, where you're generating a lot of club head speed, that tip stability section is very, very important. And we find that because we have a limited landscape with wall thickness,
Mhm.
is that in designs where we can afford to put the boron into the tip section based on its larger diameter, we get a much better performance with tip stability and a lot of the attributes that Avery just mentioned. So it's a unique material. It's an exotic material. It's relatively expensive. It's probably one of the most expensive materials that we actually put into any of our golf shafts. But it's used in areas where we're really trying to have a real stable tip under high swing speed conditions.
But it sounds like it's one of those things where if you're going to have a premium product, you're going to actually get the bang for the buck in this case. It's one of those things that if you put boron in there, again, you had mentioned you've got a finite amount of real estate in a golf shaft.
Right.
And if you want to maintain that, then you need to go into some elements that are simply just not around a lot. You're experimenting, I would assume, with all different kinds of things. This is one of those instances where you're going to be able to see and feel the difference, and be able to understand that this is part of a premium offering then.
That's correct. That's absolutely correct. Yeah.
Okay. Avery, let me kick it to you.
Yeah.
Talk to me a little bit about some of the shafts that are going to incorporate boron in them, and what are players
Yeah.
seeing and feeling once they get that in their hands?
So, the thing is, this was actually a fun one for us because one thing that we find if we use strictly just a lot of boron, for the tour players especially, the feedback comes back that the shaft is, quote, really boardy. So it's going to be almost too stiff. And this was kind of fun. So the first time we started this was back in the Tensei days, the original CK Pro. And, again, going back to Mitsubishi having vertical integration and being able to create all of our shafts from the minute we start to the minute we finish, we can test all kinds of products. So when we started working with Tensei, we actually had a bunch of different materials to test, and we were trying to find a combination that would work. So the first one to come out really with boron was the CK Pro. But what we were able to do is we were able to add a carbon Kevlar into the handle, which almost acted as a dampening. So the shaft, even though it had boron in the tip section, you didn't get that, quote, boardy feel. So the guys had control at impact, but it didn't feel too stiff. And that was a lot of fun for us. We did a lot of testing with a lot of different materials, and again, going back to the gears and the motion capture and testing with tour players. So there was a lot of product development that went into that before we launched it on tour, and it ended up being an absolute home run.
Avery, talk to me a little bit about the process when you get a new shaft and you want to bring it out on tour or have it be tested by elite golfers. How
Yeah.
often do you have to get some feedback from them. In this case, hey, maybe it was a little bit too boardy, maybe it was a little bit too soft, whatever.
Yeah.
Will you go back to somebody like Todd and say, hey, look, we need to sprinkle some magic pixie dust on this? Go into your bag of tricks, whether it's this element or this type of technology. How often do you have to go back, and what is usually the time frame in terms of when the first prototypes arrive and when
Yeah.
you then go back and say, like, we need to refine this just a little bit? How often does that really take place?
Well, we do so much R&D and product testing before we take it on tour. We want to be almost 100% that when this goes on tour that it's going to perform. So most of the feedback to Todd comes from, again, we'll do gears testing and we'll bring in, a ton of players and we'll spend weeks testing it with top players before we're going to try to launch a product. And that's generally the time frame where we'll go back to Todd and we'll say, hey, we need to do this or we need to do that. And then once we bring it on tour, yeah, it's a prototype. So if we need to make any running changes, we can. Generally speaking, it mostly works out, but there have been times where we call Todd and we say, okay, this is working great. We just need to tweak this a little bit, and then we get that done.
So let's talk about another technology that you folks have incorporated, MR70. Now, this, as I understand it, Todd, is going to be another kind of fiber that can be incorporated into golf shaft. But exactly what is MR70 and how does it benefit golfers?
So MR70, David, is an intermediate modulus fiber that we make at Mitsubishi. It's a pan-based fiber, unlike pitch-based. Its modulus is considered an intermediate modulus, so roughly 48 million psi in flexural modulus or tensile modulus. And basically, it's our highest strain rate fiber that we have. So its elongation is very high, and its tensile strength is about 20% higher than its equivalent nearest partner in our lineup on fibers. So for tip applications where we're looking for very high tip strength and elongation where it's the highest because of deflection, we place MR70 in strategic areas in the tip. So we're getting the tip stiffness benefit, but we're also able to take advantage of its high strength and high strain rates. So it allows us to reduce the wall thickness. So for very lightweight shafts, we use it heavily down in the tip section because of its strain rate and its elongation. So basically, depending on the shaft type, the kind of tip launch we're looking for, the swing speeds, we'll put it into certain designs and certain families of shafts to achieve, a specific launch condition, but with high strength.
And so, Avery, this has got to be a godsend for you because as someone who's out there on the PGA Tour quite a bit, you've seen that
Yeah.
the weights that guys are using in their driver shafts, there's still some holdouts that might be swinging some serious lumber at around 70 to 80 grams, 75 grams or so.
Yep.
But a number of big name players are now down to 60 grams or maybe just a
Yep.
little bit below 60 grams. So as you reduce weight in search for more club head speed, a material like MR70 that can do that job down in the tip section and maintain some stability
Yeah.
at that swing speed, but without adding more weight, it's got to be exactly what you're looking for.
Well, key, yeah, that's key. I mean, especially out on the PGA Tour over the last year and a half. I mean, everybody's chasing for speed and distance.
Right.
So anything we can do to make the ball go faster, to make the swing speed go up, if they can still find the center of the club face, that's extremely important. So MR70 out on tour has given us that. It's given us the stability and the feel. And it creates something where we can go lighter and these guys can swing hard at it, and they're going to have more consistency and control. So it was really fun. First time we saw it come out, we used it in the Tensei Orange line, which I think everybody saw the popularity of that on the PGA Tour. And again, what we kind of did was we replaced the Boron with the MR70, and we were actually being able to create the same exact stability they were feeling with the Boron, but with more feel. And
And
now, oh, go
And I'm
ahead.
sorry. So, and Todd, real quick, is this when you're designing parts that you know are going to be especially light? Mitsubishi has specialized for a long time in making extremely light wood shafts. It also goes without saying that this is a place where MR70 is also going to find its way into that tip section when we're talking about 40 and 50 gram wood shafts as well, right?
That's correct. That's absolutely right. Yeah, so we will, that's a good point. So depending on the category that we're designing for, and Avery just gave a good example. So let's say it's a 70-gram driver shaft, and we're going after that low handicapper type market. And that player we're trying to get into a 50-gram shaft, the materials most likely will change from, let's say, a boron reinforced tip to an MR70 tip, just because the wall thickness is going to start getting very thin down on the tip to achieve that weight reduction. So by putting big, thick, large diameter boron filaments down there, you start to reach a limit of where you could put it because of its thickness. And that's where the MR70 is a great replacement, as Avery mentioned. And then we noticed that we're picking up better feel. And I think you'll probably agree with me, in the last 4 years, we've spent a lot of time internally on the feel of a golf shaft, and improving that feel and that feedback to the golfer while he's out or she's out on the golf course and not in front of a launch monitor. So that kind of fiber, like MR70 and the X-Link resin that we're going to talk about, I think, in a little bit, lend themselves towards this improved feel and player feedback category that we're pursuing.
Avery, talk to me a little bit about some of the shafts where this technology has been incorporated, and that what you see in here. You had mentioned Tensei Orange. Are there any others that people are, or that's been a wildly popular shaft for you guys for the last couple of years, especially as driver heads, have gotten heavier? Is there anything else out there where this has been employed, or is that something that you think is a little bit more at the consumer end on the really light stuff?
No, actually, you'll see it in, for us, the Diamana is our flagship. That's our premium product.
Right.
And we've actually been able to do some really cool stuff with it. And starting back with the 4th gen and now moving into 5th gen, the TB, the PD that we actually just released and they're starting to launch out on tour. We've created, actually, it's a mix of boron with the MR70 in the tip section. So we're creating the feel and the stability.
So Tod, Avery just sort of mentioned that. How often do you sort of cross technologies? I mean, boron, you said, is a little bit bigger. It maybe weighs a little bit more. It has certain inherent advantages and disadvantages in different ways. I mean, it presents challenges. And then something like MR70 can do some things, but how often do you guys blend different technologies like this together to get the benefit you're looking for?
Good question. We actually do it all the time. It's a common process that we go through when we're looking for specific shaft properties. And, we have to take into account all aspects of a shaft design, including cost, availability, things like that. A lot of these materials are what I'd consider exotic materials, and you can't just go to the local store and pick them up. So we always look at the big picture. Playability is always first, right? That's our target, and then we have to put in other factors, and that might drive us in some cases if it's cost driven, or we have cost limitations. We might not be able to use boron. We might have to use another material. So it's a blending of a bunch of different factors.
So you're probably not going to head down to the hardware store and pick up a couple pounds of boron and start tossing it around. Yeah, I consider that to be a pretty exotic
Probably
material.
not. No.
Let's talk a little bit about the one that you sort of fed me a little bit earlier, Tod, on this one, X-Link. Now, this is one of the newer technologies, found in some of the most premium offerings now that Mitsubishi has. Talk to me a little bit about what X-Link is all about and why this is really unlocking some interesting things for you guys.
Sure. So X-Link is a resin technology that's been in development at Mitsubishi for about 5 years now. And in general terms, a composite structure is comprised of, let's say, carbon fiber and a resin, and they're combined together to form a composite, a rigid structure. And in general terms, the more fiber we can put into a structure, a golf shaft, the higher the performance, the higher the strength, the more tailorability we have. But we always have to keep in mind we have to have a certain amount of resin that goes into that structure. So if you look at the composites industry in general, including military, aerospace, and so forth, a general rule of thumb is that most composite structures consist of about 65% carbon fiber or a fiber reinforcement and about 35% resin. And those are combined to form a composite. If we want to drive the resin percentage down, which increases the fiber properties, typically what happens is you suffer strength issues like brittleness. And so that's been sort of the holy grail that we've been striving for, which is how do we build materials that are very low in resin content, but still have sufficient strength and durability so they don't break in the field. And so what we've been able to do is develop a resin system that we can drive the resin content down to like 25%, which drives the fiber volume way up and the fiber properties way up. And it's also very strong. So it has incredible impact strength, durability, fatigue strength, and so forth, compared to, like, let's say, normal epoxy resins at a higher resin content. So what that does is it allows us to increase the fiber volume in the structure, which increases lowers the torque, increases the feel, and increases the strength.
Yeah.
So
let me get this straight. You basically, to borrow my 16-year-old son's parlances, you found a cheat code. And if the carbon really is going to inherently give you, the more carbon you have, the more feel, which everybody wants. But
Right.
if you get too high in carbon content, durability, brittleness, that starts to become a real problem.
Right.
This, by adding this formulation of resin, gives you the cheat code to say, like, okay, we can go way higher than we've ever gone before with
Right.
carbon, which is great. And we don't get the problems with the durability and the brittleness. Do I have that correct?
That's absolutely correct. Yep.
Yep.
That's absolutely correct. And on the feel side, to take what you just explained very accurately, by the way, is I like to liken this to like a Stradivarius violin. I mean, if you look at the wood in a Stradivarius violin, the reason that they're so unique and different is, you know, he would go out into the forest and he'd find slow growth or old growth wood to make his violins out of. So the fiber component in that wood, which is a natural composite like bamboo, was very high. And so the attenuation of frequency in sound is very similar to frequencies that come up through a golf shaft, just one sound and one's feel. So what we found is these high fiber volume structures give us much better feel coming up through the shaft, just like a violin, just like spruce in a violin. So
Avery, now you know why you sound so good in the evening. You and your Stradivarius, you know,
Yeah, that's exactly right.
That must be it. Talk to me a little bit about, so I would assume that because this is a new, and this is, Todd, this is proprietary and this is only for Mitsubishi at this point?
That's correct. Yeah.
So Avery, I would imagine that being able to bring parts like this, what are some of the shafts that are going to feature X-Link at this point, and what has been the reaction when players have tried them?
So you'll find it in our 2 premium shafts. You'll find it in the Tensei 1K, which we've talked about before. So 1K actually is going to have the X-Link and Boron, which we just talked about. And then you're also going to find it in our 5th gen, which has the Diamana TB. You've seen that out on tour probably over the last year. A lot of success with guys out there with the Diamana TB. And then we're actually moving forward now with PD. So we're going to start launching that probably over the next week or so out on tour. But that's going to have X-Links, Boron, and MR70. So talk about premium.
Now you're throwing everything at this thing, but it's really interesting to hear you guys talk about how you try and, Avery, get feedback from people on tour. Tod and his team are tinkering away in their mad laboratory. And when you put these different things together with all types of different technologies and different materials, many of which are going to be proprietary and only found in Mitsubishi shafts, you can very quickly make subtle modifications if necessary, but your research and your development is allowing you to really fill up every hole that I would imagine would be on a club fitter's wall. I mean, if a player is high swing speed and needs low torque with tip stiffness, got it. If somebody needs lower speed, you know, they're looking for the ultimate in lightweight, but they still want to have some performance, you have materials and technologies that allow that to happen too. It's, Avery, your job is easy. You've got everything you need.
Exactly. Thanks to Tod.
Excellent.
The engineers.
Excellent. Listen, guys, I've learned a whole lot. Really, it's great to hear how this very technical stuff explained in plain English for people like myself. Thanks very much for explaining it all to me.
Thanks,
David.
I appreciate your time.
Likewise. Thanks, David.